Namaste! I'm Dr. Kapoor. Today, we're diving into something that feels a little bit like magic your very own digital lab book. Imagine a place where your ideas don't just sit on a page, but actually spring to life. Ready to see how it works? Just think about it for a second. The ancient rishis had their sacred texts, their powerful mantras. What if you had a kind of magical parchment where anything you wrote could instantly appear right in front of your eyes? Well, guess what? In our world, we have something just like that. And today, we're going to learn how to use it. Okay, so every great scholar, every scientist needs a place to do their work. For us, here in the digital age, that place is our coding environment. So let's start by getting to know the tools we'll be using to give our instructions to the computer. Now, the most basic tool we have is something called a code editor. The best way to think of it is like a simple blank piece of parchment, a patra, and a pen, a lekhani. It's just a clean, simple place for you to write down your instructions, no distractions. But we can do better than that. We can upgrade to something far more powerful called an IDE. That stands for Integrated Development Environment. Now, this isn't just a blank page. Oh no. This is like a complete scholar's desk. It's got your pen, but it also has a guide, like a Shabdakash, to help you find the right words, and a corrector of Yakran to spot any mistakes you make. It's like having a team of assistants helping you out. So, what's the big difference? Well, a simple editor is really just for writing, but an IDE is a full workshop. It's one single place where you can write your code, check it for mistakes, and then actually run it to see what happens. It makes everything so much faster and easier. All right, now let's talk about a really profound idea that's at the heart of how all of this works. In our tradition, we have this beautiful idea of the plan versus the action, the intention versus the actual deed. We call this sankalpa and kriya. I want you to picture a master sculptor, a shilpi. Before they even touch a block of stone, they see the final murti perfectly in their mind. Every curve, every detail, it's all there, a flawless vision. That perfect mental plan, that's the sankalpa. But a plan in the mind doesn't create a sculpture, does it? The shilpi has to pick up their tools and actually start carving. That physical work, that is the kriya. This is a perfect metaphor for our code. The file you write, that file ending in .py, that is your sankalpa. It's your detailed, perfectly structured plan. It has all the instructions, but as long as it's just sitting there as a file, it's silent. It does absolutely nothing on its own. And the run button, you guessed it, that is the kriya. The moment you click that button, you are starting the action. You're telling the computer, take my plan, take my sankalpa, and bring it to life. Follow every single one of my instructions. This is the moment your plan becomes real. So let's do it. Let's perform our very first kriya. This command here, print, is one of the simplest. It just tells the computer to display whatever text we put inside the quotes. When you run this, you'll see the words, "Hello world, I am ready to analyze data," appear on the screen. And just like that, you've successfully given the computer its first command. You know, ever since Aryabhata gave us the concept of shunya or zero, our land has had a deep, deep connection with the wisdom of numbers. And your computer is a direct inheritor of that legacy. It's an unbelievably powerful calculator that follows the rules of logic perfectly. Let's see it in action. The computer understands the basic language of math through these very simple symbols: a plus sign for addition, a minus for subtraction, this little star or asterisk for multiplication, and a forward slash for division. It's a universal language, really. Okay, time for a little puzzle. Using those ancient principles of logic that you've learned in math class, the BODMAS rule, what's the answer to this? 10 plus 5 times 2. Now think carefully. Is the answer 30 or is it 20? The answer is 20. And this shows us something really important. The computer doesn't just read from left to right. It follows a strict order, just like BODMAS. It knows it has to do the multiplication first, the 5 times 2, and then it does the addition. It's always precise, always logical. So we've made the computer talk. We've made it do math. But what if we could make it draw? What if we could turn our logical instructions into beautiful visual art? Well, to do that, we need to unlock a really powerful new idea called libraries. So think about it like this. Basic code gives you a simple toolbox, a hammer, a screwdriver. But what if your project needs a power drill? You're not going to build a whole power drill from scratch, right? You'd go to a workshop and borrow one. A library in coding is exactly that. It's a collection of advanced, specialized tools that other experts have already built for us. For our next task, we need a special drawing tool. So we're going to borrow a very powerful library called Matplotlib. Our mission is to give the computer a simple math equation, y equals 2x plus 1, and have Matplotlib draw the graph of that line for us. And here it is. Just look at that. With just a few lines of code, a few simple instructions, we've created this perfect, clean graph. We didn't draw a single dot by hand, we just described the line using logic, and the computer created the art. This is the amazing power you get when you combine your code with these incredible libraries. Now, this next part is where everything changes. This is the moment you stop being just a student following instructions and you become a scientist. The real magic of this digital lab book is the power to experiment, to change things, and see what happens in an instant. And this brings us to the very heart of scientific discovery. It's a simple process called the edit and rerun cycle. You have an idea, a hypothesis. You edit your code to test that idea. You rerun the program to see the new result. This simple loop is exactly how real scientists and data analysts explore the world and find new knowledge. Let's try an experiment. On the left, you see our original line, y equals 2x plus 1. Now, what do you think will happen if we change that 2 to a 5? Let's edit the code and rerun it. And look, the new graph on the right shows the line is now much, much steeper. We just did an experiment that proves how the m in y equals mx plus c changes the slope of a line. Okay, on to our next experiment. We'll reset back to our original line again, y equals 2x plus 1. This time, instead of changing the 2, let's change the plus 1 at the end to a plus 5. Watch closely. We run it and see? The steepness, the slope is exactly the same, but the whole line has shifted up on the graph. We've just shown how the c value moves the line up and down. So, I want to leave you with this one question to think about. Just now, you changed a variable, you observed a result, you tested an idea. How is this cycle of editing your code and rerunning it any different from what a scientist does in a chemistry or physics lab? Think about that, because you have just taken your first step on the path of scientific discovery. Wonderful work today.